get out your inverse trig function notes. I don't think they say inverse trig functions, but that's what we're talking about. We want to talk about inverse trig functions. Now, what does an inverse function do? An inverse function undoes a function. In other words, if I put in x and get out y in a function, the inverse function allows me to put out the y value, the output value, and get back to the input value. For example, an example of an inverse function would be if I have y equals x squared and y equals the square root of x. Those are inverse functions, because if I put in 2 for x, I would get 4 for y in this function. If I put in 4 for x, I would get 2 for y in that function. So 2 squared is 4 and the square root of 4 is 2. They undo each other. And I'm going to erase this now because I need this room maybe for something else. But that's what I mean by an inverse function. They undo each other. So in trigonometry, the functions that undo each other are called sine and inverse sine, cosine, inverse cosine, and so forth. So this little symbol, sine to the -1 of x, means inverse sine. Another way you will see this written is y is equal to arc sine of x. They mean exactly the same thing. So you'll see that you'd be able to use those interchangeably. Now, if the x and y's switch places in an inverse function, they also switch places in the graph. So I've got this graph labeled. It's actually labeled in degrees, but I put the radians down here because I really want you to be more comfortable with radians right now. So you can see that this point is 91, but it's also pi over 2, 1. So you'll see the angles kind of in both directions. What I wanted to do and what I want you to do is we're going to take every one of these key points on the sine graph and we're going to switch the coordinates and we're going to sort of graph it. We're going to graph the inverse. We're going to graph it backwards. So instead of having all the angles on the x-axis and the trig values on the y-axis, we have all the trig values on the x-axis and the angles on the y-axis. So for example, the point 0, 0 will still be 0, 0. So we'll plot that. Now what about the point pi over 2, 1, or 91? Now it's going to be 190, or 1 pi over 2. So that we're going to plot that right here. And then we have 180, 0, so we're going to have 0, 180. And then we have 271, so now it's going to be 1. Actually, that's a -1. It's not kind of hard to see. 270, -1, so now we're going to go to -1 here and go up to 270. And then our last one is 360, 0, or 2 pi 0, and so we're at 0, 2 pi. So notice what I've created is the curve that goes the other direction. Instead of winding around the x-axis, now it's winding around the y-axis. Now if we continued this backwards, we'd also have a point at -90 would be at -1, at -180, 0, at -270, notice we're up to +1 here, and then back down to 0. And so here's what the inverse graph looks like. So that tells me if I put in the trig value, I should be able to get out the angle. So we're going to look at some examples of this on the calculator. So you want to get your calculator out. And I said here, put your calculator in degree mode. But I think we're fine if we just want to stay in radians. So if you just remember, we can use pi over 6 here and -pi over 6. Here at 150, we're at 5 pi over 6, and at 210, we're at 7 pi over 6. So we're going to look at some of these angles and look at their trig values. So on your calculator, I've got some other stuff on here. We can ignore that. But on your calculator, we're going to start out by putting in sine of 30, which is sine of pi over 6. Pi divided by 6, and that's 1/2. Now let's try inverse sine of 1/2. That should give us pi over 6. So we go to trig button and notice we have our inverse sine is right below the sine. So inverse sine, and I'll show you something nifty your calculator does. If you just up arrow to 1/2 and then push enter, it'll automatically type it in there for you. Pretty nifty. And we get pi over 6. So you can see that the inverse function just undoes the original function. Now let's do sine of -pi over 6. So I'm just going to go up arrow until I get to sine of pi over 6, and I'm going to bring that down and I'm going to edit it, and I'm just going to go in here and make this negative. So sine of negative pi over 6, negative 1/2. Then I want inverse sine of negative 1/2. So inverse sine of negative 1/2, and once again I can just up arrow to that and copy it and push enter, negative pi over 6. So good so far. They're behaving exactly what I expected them to do. So you can fill in the blanks for the answers on those, inverse sine of 0.5 and negative 0.5 and so forth. Notice that inverse functions undo each other. That's what I have for the blank there. Now, let's look at sine of 150. Well, sine of 150 is sine of 5 pi over 6. So let's go to sine. Actually, I could have just gone up there and captured it, but I'll go ahead and type it in. 5 pi over 6. And push enter. And notice we also get 1/2 here. So it's the same as we got for sine of pi over 6. They have the same trig value. Now if I do inverse sine of positive 1/2, so inverse sine of 1 divided by 2, sine of pi over 6. So in this case, I put in sine of 5 pi over 6 and got 1/2, but when I did inverse sine of 1/2, I got pi over 6. I didn't get 5 pi over 6. And that kind of makes sense because why should it give me a different answer than it did up here? I got inverse sine of 1/2 gives me pi over 6. So we have an issue here. We got a little bit of a problem. And you'll see the same thing if I do 7 pi over 6. And I'm just going to edit this. I'm going to go up and grab this and edit it and change it to 7 pi over 6. And if I do inverse sine of negative 1/2, so I'm going to go grab my inverse sine, edit that, make that negative 1/2. And notice I'm back to negative pi over 6, not to 7 pi over 6. So we have an issue that we need to deal with. So let's go back and look at your graph and see what the problem is. The problem is here that if you look at this graph, is this a function? Well, no, it's not a function. For a function, each element of the domain, each x value, is paired up with exactly one element of the range, or one y value. Each x value goes with one y value. You notice here, if I put in the 0.5, I get there's two different y values. There's my pi over 6, and there's my 5 pi over 6, or my 30 and my 150. Those have the same trig value. Got a problem here. If I put in my negative 0.5, there's my negative pi over 6, and here's my negative 5 pi over 6, or up here would be my 7 pi over 6. So there's my 7 pi over 6. So I'm getting multiple y values for each x value, and that's not a function. So we have to limit the range of our function to a certain section right here. And all of our values that we get for inverse sine are going to always fall between negative 1 and 1. So this section of the graph gives me all of the values from negative 1 to 1. But when I do inverse sine of any of those values, I'm always going to get an angle that's in between negative pi over 2 and pi over 2. I won't get these other angles. Even though they have the same trig value, my calculator will only give me angles between negative pi over 2 and pi over 2 for inverse sine. Now let's take a look at inverse cosine. Inverse cosine, here's our points. Let's go ahead and draw the graph for this. If we were to reverse the points, at 0, the trig value is at 1. So when the trig value is at 1, the angle is 0. Actually, I'm going to put that in blue. When we're at 90, we're at 0, so I have 0, 90. When we're at 180, we're at negative 1, so I have negative 1, 180. And then 0 at 270, and then 1 at 360. And then I could go backwards and do the same thing. At negative 90, I'm at 0. At negative 180, or negative pi, I'm at negative 1. At negative 270, I'm at 0. At negative 360, I'm back up at 1. So here is my inverse cosine graph. Oops, kind of went off, lost my grip on the pen there. Now if we look at calculating these, let's look at some values where, and I've noticed I'm picking where things turn out to be nice numbers. Cosine of 60, well, we can do pi over 3 for 60, and we can do 2 pi over 3 for 120, and we can do 4 pi over 3 for 240, and we can do 5 pi over 3 for 300. Notice that I'm picking angles that all have a reference angle of 60. So they should all have similar trig values. So when do we get these values on the calculator, and when don't we? So let's put in pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 on the calculator and see what our cosine values are. So let's go to cosine. We'll start out with pi over 3, and then I'll just go in and edit this each time as I enter additional values. So pi over 3, 1/2. Now let's do 2 pi over 3. Negative 1/2. 4 pi over 3. Negative 1/2. And 5 pi over 3. Positive 1/2. So I want you to notice we went negative in quadrant 1, or positive in quadrant 1, then negative, negative, positive, which is corresponds with what we know about cosine. Positive in quadrants 1 and 4, negative in quadrants 2 and 3. Now, let's try inverse. Notice if I do inverse cosine of 1/2, there are two possible angles that I've done that I could maybe get. So which one do I get? When I do inverse sine of negative 1/2, which angle is the calculator going to give me? So, on to inverse cosine. Inverse cosine of 1/2 gives me, oops, I forgot the inverse cosine, I just did cosine. Not terribly helpful. Let's try that again. Inverse cosine, oh, sorry, little calculator issues here. Inverse cosine of 1/2, that gives me pi over 3. So that takes me back to the very first value I did. Cosine of pi over 3 is 1/2. Inverse cosine of 1/2 is pi over 3. So you can fill that in. Now let's do inverse cosine of negative 1/2 and see which of the angles I get. I get 2 pi over 3. Okay. If I do inverse cosine of 1/2, I'll always get pi over 3. If I do inverse cosine of negative 1/2, I'll always get 2 pi over 3, even though there are other angles that have the same trig value. So if we look back at our graph here, we see that I'm always getting an angle in quadrant 1 or 2 when I do inverse cosine. That would correspond to this section of the graph right here. Because that's this piece right here of the graph, it's this section of the inverse graph. Notice that I'm always going to get an angle in quadrant 1, 0 to 90, or quadrant 2, 90 to 180. So this little red section is the graph of inverse cosine, just like this little red section up here is the graph of inverse sine. In inverse sine, the section of the graph that I'm looking at for my inverse function is from there to there. That gives me every possible trig value represented, but limits the angles so that I actually have a function. Now let's look at tangent. Tangent, I already drew the graph in for you. Now let's think about the inverse tangent. Inverse tangent reverses everything. So here we have vertical asymptotes, here we're going to have horizontal asymptotes. So let's draw in the horizontal asymptotes. You see that they are halfway between 0 and 180 at pi over 2, 3 pi over 2, and so forth. So here we have pi over 2, and 3 pi over 2, and negative pi over 2, and negative 3 pi over 2. Those are our asymptotes. Then we need to look at our zeros. Our zeros are halfway in between the asymptotes, but instead of being on the x-axis, they're going to be on the y-axis now. So these are places where tangent is equal to 0. So when we put in 0, we get these angles. Then we have to look at pi over 4, which is halfway between 0 and pi over 2. I'm at 1. So I go to 1 on my x-axis, and that takes me to pi over 4 right here. And I go to negative 1, and it takes me to negative pi over 4. And I could draw And I'm just going to draw them, kind of freehand them here. Here are the different curves that I get for inverse tangent. Now once again, if I do inverse tangent of 40, if I do tangent of 45, 135, 225, 315, notice I'm once again picking nice angles that give me nice trig values for tangent. And these are all of our 45-degree angles: pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So on the calculator, let's take a look at those angles and see what kind of trig values I get. So we'll start out with tangent of pi over 4. So we go pi divided by 4, and that gives me 1. And then I'm going to go up and edit and do 3 pi over 4, 5 pi over 4, and 7 pi over 4. So there's 3 pi over 4, and oops, and 5 pi over 4. Okay, so notice we have 1, negative 1, then 1, and then 7 pi over 4. So this confirms what we already know about the unit circle. Tangent of, in quadrant 1 is positive, in quadrant 2 it's negative, then it's positive, and then it's negative. So probably pretty sure that if I do inverse tangent of 1, I'm going to end up with pi over 4, because that always seems to happen. We always get back to quadrant 1. Quadrant 1 is kind of our go-to quadrant. So inverse tangent of 1, sure enough, gives me pi over 4. But which quadrant am I going to get? What am I going to do when I do inverse tangent of negative 1? So let's do inverse tangent. Go in and edit that, make that negative 1. Interesting. There were 2 places up here where I had 3 pi over 4, 7 pi over 4, where I got negative 1. But when I did inverse tangent, I got negative pi over 4. Just like when I did inverse sine of negative 1/2, I got negative pi over 6. So what this is doing is this is taking me backwards into quadrant 4 as a negative angle. So if we go back and look at our graph here, that should make sense. The section, what I did was positive pi over 4 is right here on the graph, and negative pi over 4 is right here. That corresponds to these 2 points on the inverse function. When I put in 1, I got positive pi over 4. When I put in negative 1, I got negative pi over 4. So the section of the graph that the calculator will use for the inverse function, or that is defined to be the inverse function, is this center section of the graph, which makes sense. So for each of these graphs, we're picking the place that's closest to the origin that includes both positive and negative trig values. So with tangent, it's this center cycle. We go back. With sine, it is also quadrants 1 and 4. Negative, positive quadrant 1, negative quadrant 4, close to the origin. We can't do that for cosine, because if we did quadrants 1 and 4 positive and negative, we'd only get the positive trig values. We need some negative trig values, so we do quadrants 1 and 2. Now we'll be building on this in our next section of notes, and we'll talk. I can briefly show you the inverse functions, but this gives you kind of a brief overview of inverse trig graphs, and we'll go from there on Tuesday. Actually, I probably shouldn't say the day, because if I use this another year, it might not be Tuesday, but well, the next time we meet, let's put it that way.